Object-Oriented Classification tutorial. A tutorial on how to use open source software, their free application in QGIS, and remotely sense data to perform object-oriented classifications. Instructions compiled by Miguel Pavón, working with the Bird Conservancy of the Rockies for the Desert Landscape Conservation Cooperative, DLCC. It's not every day that you say, I want to make an object-oriented classification today. Check land cover classes over time to evaluate and document where current land management practices are helping to conserve habitat and landscape. We need a plan, some ingredients and methods. Next, we are going to talk about ground truthing, how to develop training polygons and accuracy assessment polygons. Hello. Hi, my name is Miguel Pavón. I'm working with the Bird Conservancy of the Rockies for the DLCC and also the Desert Landscape Conservation Cooperative. On how to make an OOC, how to make an object-oriented classification work. It's not every day that you wake up in the morning and say, I want to make an object-oriented classification. And then you go to the grocery store or you can go to the bank. There is some planning involved in it. You need to figure out what kind of remote sensing imagery you are going to use. You need to figure out the time of the year that you want, or if you want multiple times of the year. And also a very important thing is to get your ground control points, your reference training polygons, your ground truthing. Like for example, today we are at a grassland and we are going to talk about how to collect ground reference polygons here in this grassland. So in the past, we needed a GPS unit and a notebook and camera to make that work. A GPS units come in different kinds of prices and ranges. This is one of the cheapest ones. The camera is also one of the cheapest ones that you can have. Also, some people now can use their smartphone. What we can do here is to take pictures, notes, and GPS coordinates. Like for example, we know that we have a set of latitude and longitude at this point. Let me show it to you. And we also know that we can use those coordinates on top of a concurrent Landsat image to develop a grassland polygon. We know that every pixel in Landsat is 30 meters by 30 meters. How big is 30 meters? Let me go as far as 30 meters, and one pixel will be approximately that distance times 30 meters wide. Let's do that. Note that at this latitude, 1 arc second is approximately 100 feet, 30 meters, or 1 Landsat pixel. This is 30 meters long. By 30 meters wide. There it is. I just walk around 1 Landsat pixel. There are several pixels of grassland. That should be visible in a concurrent Landsat scene. We take one picture from the top, nadir, and 4 oblique pictures in the 4 cardinal directions to give us an idea of how big is this extension of grassland. Looking east, looking south, looking west, and looking north. We can record our coordinates with the compass app in our phone and capture it, and or also with our GPS unit. So we make sure we have our pictures from top, down, and 4 cardinal directions. Our next class to capture is water. Make sure that you have several reference polygons, 10 or more, per class that you want to map. Take pictures in the direction of the water. Water polygons may be tricky because we do not have a boat to capture a point. What you can do is to take some notes and take your GPS reading as close to the water as you can. So we have our water GPS location. Our next class to capture is bare earth. We take several locations and several photographs per location. This is our forest class. We capture several locations and several photos per location. Agricultural classes may have a mix of crops. Urban class will be a mix of concrete, asphalt, buildings, cars, and some green areas. Capture a variety of locations with several conditions. The last class for which we take coordinates to create reference polygons is brushland. It may be a mix of bushes with grasses. Repeat until you have a good number of samples, 10 or more per class. Practice will make you gain confidence with the number of samples needed per class. Remember that you need reference polygons for the training declassify process and different ones for the accuracy assessment.